right now?
Yep. So if you just present.
Wonderful. That's almost equivalent. And how about you have submitted an issue, you have downloaded and tried Kubeflow, figured out something was wrong, and let us know about it.
Thank you.
Okay, I want
Thank you.
way more hands up for that question in 6 months.
All right.
Are you ready?
Yep.
Awesome.
Thank you, Thea. Thank you, Ed. Hello, everyone. My name is Pavel. I'm an engineering manager in the Kubeflow Pipelines team. So I'll talk about the Kubeflow Pipelines, a relatively new project that was added to the Kubeflow ecosystem. And then just to gauge where I should start. So raise your hand if you have seen this project and tried it out. Okay, good. Thank you. So I'll go through a quick overview of the pipelines and the architecture of the project, and then I'll drill down into a bit more details on the metadata store and metadata APIs that we are introducing into the system, and then I'll talk about the authoring experience, how to build your own pipelines, your own components. What are all the ways that exist to do it right now, and then. We'll give some overview of the upcoming features as well. All right, so the project, the Pipelines project was introduced to Kubeflow in November in 2018. So it is available as part of sort of default Kubeflow deployment through one-click app into GCP and then through the CLI tools. So the main goal of this project is to help our users to orchestrate complex ML workflows. We've seen users doing training, serving, data pre-processing, but there was a need to sort of combine all these activities into a single deployable workflow that can be operationalized and productized as one single thing. That would also enable reproducible and reliable experimentation so that the activities that happen during the model development and then model debugging can smoothly translate into the operational world and then run at scale there. And then as part of that, another goal we had is to enable composition of those pipelines through reusable components. That can be shared across developers and data scientists. So what constitutes a pipeline? Each step in a pipeline essentially is a containerized ML task. So it has a container image behind it, which ensures that the execution and the environment of that code is reproducible across various deployments. You can take one of the components that we have in our library, that is in AI Hub, and you can build your own as well. So, and then when you construct the pipelines of those components, you can attach Kubernetes objects to that, such as volumes and secrets. So the specification of the pipeline is done through what we call Python DSL, or the domain-specific language is also, it can be looked as an SDK. And then in that specification, the dependencies across components and steps are inferred from the data that has been passed around across those components. So the pipeline can be parameterized as a whole, and then by specifying the parameters, essentially instantiating a run, and that run becomes the entity of management that runs in the cluster and being sort of managed as a one atomic thing. And then the runs of the pipelines can be scheduled to occur on a regular basis, or it can be invoked through an API. So an example of the pipeline is a TFX pipeline, and TFX is a TensorFlow extended. That's a platform that is used internally at Google for running large-scale machine learning workflows. And then recently, just last week at TTF Summit, we had an announcement of supporting TFX on top of Kubeflow as well. And then as part of that, we support all the TFX components that are that have been released. So there will be later a lightning talk on this subject to drill down into more details. So here is a kind of a 10,000 feet view architecture of the pipelines services. So essentially, that's a collection of microservices running on Kubernetes and Kubeflow, and then the main parts there is the API server that exposes all the APIs to manage the pipeline templates, experiments, and runs with them within them. There's a metadata store behind that stores all the tracking information about the running workflows. So we integrate with TensorBoard and notebooks for data visualization and an interactive experience. And then underneath the cover, we use Argo as the main workflow orchestrator. And then the workflows themselves can use various services externally outside of the cluster as well as inside the cluster where they're running. And then one of the biggest thing in this architecture is also the SDK/DSL part that allows the users to construct the components and pipelines. So that consists of the DSL compiler and a set of tools to describe the schemas and describe the inputs and outputs of the components. I'll talk about this in a later slide as well. So the project is available, like I said, under Kubeflow GitHub. So we do weekly releases, so we're continuously releasing new features, keeping track of bugs. So there's a macro design document that was published a few weeks ago. So please take a look at that. And then we have a roadmap for 2019. So please submit issues, design proposal, and your use cases. We already are working with several community members on integrating various features and solutions into the system. So the contribution can come in various forms and factors. One is, and probably the easiest and the most straightforward way, is to contribute components and the pipeline examples that are integrating with different services or demonstrating different uses of different use cases in the ML landscape. But it also contributions in the core infrastructure as well. For example, things like volume management or artifact management that we had seen. So a few words on the pipelines and metadata. So metadata is a fundamental layer in Kubeflow and pipelines in general. So it is the place that both serves as the store of the metadata records about everything that happened in the system, and it also a source of information that can be used for orchestrating and executing the workflows. So an example of that usage is shown here on the slide as contrasting the difference between two execution modes of the tasks. So one is the task-aware execution, where the tasks are executed one after another, after one is completing, we running the other one. And another mode of execution where the tasks are independent from one another, and the dependencies are only declared on the data that is produced by one task and consumed by the other. So in this case, the dependencies are implicit, but that mode enables a more scalable execution and a more decoupled development of those tasks. So both modes have been enabled through the metadata, and they have different use cases that they can be applied to, but there are certainly advantages of running the pipelines in the data-driven in a data-aware mode. So, and metadata enables this. So what's inside the metadata store? Just the most recent release of pipelines, 112, had introduced the first version of the store that we currently using within the pipelines, and then we started a discussion with the community on the building a higher level APIs and integrating with more services within Kubeflow as well. So one of the core concepts in the store is the separation of the core entity schema and the types that can be defined for various artifacts. So the core entity schemas that are being sort of hard-coded into the systems is fairly simple. So it really consists of the executions, artifacts, and the types. So executions are the things that have run and have consumed or produce something. An artifact is the object that actually been generated or used by the execution. An event is the entity that connects those two together, indicating that an artifact is being used or produced by an execution by an executable. So so that enables us to track pretty much all aspects of the pipeline runs. So including the dependencies between steps and the very strong versioning of the executables and the artifacts that have been produced, and knowing which type describes the artifact. So on top of that store, there's an API and a notebook SDK as well to help to explore what's inside the store. So the things that are sort of being logged into the store today is the executables that essentially every step on the pipeline has been logged. Then all the artifacts that are produced by the steps are also being logged. And then there are some core types that we have defined into this in the system that that comes out of the box. And in addition to that, you can define your own types. As kind of a side effect of this, so the entire lineage of the graph has been tracked as well through the dependencies between executables and the artifacts. So there's some examples of how the metadata can be used. For instance, to find out what was all the inputs that were used to build a particular model. So because we know how the steps depend on each other and what artifacts have been produced, it's fairly easy to trace back from a produced model all the way down to, or all the way up rather, to the data sets and schemas and all the other files that we used to build this model, or compare various runs of a pipeline. A bit more advanced mode that has not been implemented yet is reusing of the previously computed results, so that since the pipeline is aware of what artifacts have been produced by previous version, and it can do a strong type check and a strong signature check on the executable, it can determine whether or not a particular step already been run in the past. And then that enables iterative mode of execution where a user can modify downstream modules and run the entire pipeline again, and then all the upstream modules will not need to run again because the results already exist. So that obviously will need to come with an ability to override the cache behavior and execute anyway if there's a non-deterministic behavior, non-deterministic logic inside the component. So the metadata APIs in the store can be used from any microservice within Kubeflow, but there are also advantages of using the metadata from the pipelines, and then those advantages come from the fact that pipelines describe a good structurally describe both the flow of executions and the input-output schemas. Because the system knows about all of these parameters of the workflow, logging all the properties of executables and all the input-output schemas and the locations of the data are really done automatically. So the user does not need to write any code to log that information. All of that logging happens by the system automatically and gets recorded. In addition to that, the component logic can access the metadata store to just arbitrarily query the various artifacts and elements to decide what to do. So example of that can be a step, for example, that compares the currently produced model with the previous version of the model. So the notion of the previous version of the model would really need to be understood by the comparer, but and the comparer can work with the metadata store to retrieve that previous version and compare the newly produced model with the previous one, and then do it as part of pipeline execution to decide, for example, whether the new model should be pushed to production or not. So here's a few examples of actually using the metadata. And this example shows using the metadata to retrieve the artifacts. So after running the pipeline, it connects to the metadata store to retrieve the produced models. And in this case, it pulled out two models that have been produced by two different versions of the pipeline, of the same pipeline. And another example showed the schemas that have been inferred from the data. So that is the case is available in a notebook use or in any Python code, really. So and then the same thing applies to the writing to the metadata store. Any code that runs within Kubeflow can easily connect to the store, and then both sort of define the type and log the artifacts and the executables there. So onto pipeline SDK and then component creation. Pipelines, like I said earlier, currently can be defined in a Python code by using the SDK and then connecting by creating the operators and connecting with each other. So this example shows authoring of a pipeline with these components here, where the connections between components are inferred from the output data of the upstream components that are consumed by the downstream components. So we have methods in the SDK to compile that pipeline into a file that then can be uploaded and run into the pipeline dashboard. And then there's some examples of actually that show definition of various sample pipelines today. So now, creating your own components. A component is the core part of the pipeline. And then a component has a container behind it. And this container can either be created in a kind of a typical standard way as you create containers from code using any libraries, any dependencies, just package it up. And then in order to use it in a pipeline, you would need to create a container operator that describes the argument schema of what are the expected arguments in order to parameterize that container. So that would need to be done in the Python code. So another way to create a component would be to build it directly from code in a notebook. So that capability had been released fairly recently, and then that enables you to avoid the creation of the Docker containers completely. So you can write the code for the components directly in a notebook, and then take those functions and convert them into the components on the fly. So that also enables one interesting effect that of creating a component descriptor file, which then can be shared with other users. And those users can load that component descriptor file up and create an operator on the fly without seeing the code, without seeing the dependencies, without necessarily seeing all the details of how that component has been created in the first place. And then then the user can take those files and build a pipeline out of them. So an example of that component creation is shown here in this little notebook snippet. The code of the component here is skipped because it can be fairly large, but the key parts are shown. So the Python component is the decorator here that declares the fact that this function is representing the component logic, and then the call into the compiler essentially creates an image in this case. So you can build out that image without leaving the notebook environment, and then that both builds the image and builds the descriptor of the component that can be then used as part of a pipeline construction. So in a more simpler way of creating the component without building the Docker is shown here. So here, obviously, the logic here is super simple to just illustrate the main concept of just adding two numbers together, and then but this logic can be extended to really arbitrary code, and with the single SDK code, this function can be converted into component, which then can be added to the pipeline construction code, and also as part of this call, you can save the component definition into a file, which then can be shared between environments. So that component definition file has all the necessary data to be able to load the component back up and embed it into a pipeline. So as part of the new releases of the service, we also are building a set of predefined components. So the set of predefined components that are already available on the GitHub allow you to connect to some Google GCP services, and one of the examples shown here is a BigQuery component. And then, so you can follow the code here and see how easy it is to just load that component into your code, specify the query. In this case, it's a BigQuery from a public data set, and then plug it into your pipeline to then use the data subsequently in other steps. So there are more of these components that are going to be released soon, and then there's also a sample component that you can use to you can use as an illustration of how to build more components like that. So a few upcoming features of the Kubeflow pipelines in the next quarter or so is actually the first one, the cluster upgrades, has been already released. So so that's a feature that allows you to operate the cluster on a long grinding mode, such that whenever there's a new version of the pipeline services available, you don't have to tear down and rebuild the cluster. You can upgrade the cluster in place without losing the state, so that all the metadata store data about your tracking information about the experiments and runs will be preserved during this upgrade. Like I said, more components will be coming, and then the ability to share and reuse those components. So as part of both the metadata integration and the component development effort, we will enable the component authors to define stronger type schemas on the inputs and outputs, such that we can validate the compatibility of the components within the pipeline as they compatible with each other. So if a downstream component expects the URL to read a model, then there better be a model sort of be passed down from the upstream component to it. So those checks will be performed at the compilation stage, so very early on in the development cycle. And then there's more work to be done on our side to get the metadata integrated more properly into the system as well. So so that's the overview I've had so far. So have any questions?